Yeah, that's the amazing potential breakthrough here is we are really talking about addressing immunoaging without suppressing the immune system itself. I think we've seen this in, uh, I don't know if I've got this exactly correct, but I think there's a whole category on Alzheimer's that was targeting uh, the amyloid, and it was the gamma secretase inhibitors. And so, like, they'd wipe out amyloid, and amyloid's actually a necessary inflammatory response in the brain. And so, obviously, you don't want too much of it, but you need some of it. Otherwise, you're not going to end up in a good outcome. So
Yeah.
very, very interesting. Um, so, um, so you want? Can you talk a little bit more about the therapeutic target? I know we got to be careful with intellectual property, but this DRP1 Fis1 target,
Yeah.
in layman's terms, maybe a little bit more about why that's important. I know you hit on a good amount of it just there, but if there's anything else you want to just crystallize
Yeah.
there before we
Yeah.
move on.
So DRP1, just very broadly here, because we can go down the rabbit hole really far on this topic. But it's a protein, an essential protein for the regulation of mitochondrial function. It's basically a lasso that cuts the mitochondria physically in half. Uh, and it was a target that people wanted to drug and have been drugging for a while. They've been studying it for 20 years at least. And we know that it's linked to neurodegeneration and many diseases. But the problem is that it has essential functions. Like so many proteins, the body probably wouldn't have it if it wasn't doing something important. And so the only way we really knew how to drug it was through its active site, which is non-specific. It just shuts off DRP1 generally. And we know that if you shut down DRP1 generally, you can actually induce inflammation because it's like the gardener of the mitochondrial network.